Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to continue with our departure sums, question number 6, question number 7, question 8. So far we have done the first 5 questions. I hope you have understood them, you have learned from them something new and now you feel confident in solving them. So let's continue with question number 1 of today, that is question 6 from the chapter. It says aircraft leaves location Juliet J from 36 south 130 14 minutes east at at 0946 UTC, flying a rumline track of 270, a flight level of 100, temperature of 0 degree, Mach number of 0.81, wind component we have tailwind, and you have to find aircraft position at 10:04 UTC. At 10:04 UTC. Okay, over here. So now we have the initial flight time. We have the initial flight time which is equal to 0946 and final flight time is 1004. That means the duration of a flight is how long. So that means we have flown this flight from 0946 to 1004. So total flight time will be 10 hours 4 minutes minus 9 hours 46 minutes. So how to put hours and minutes is that you put 10, number 10, then there is a degree and minutes button. Okay. So total duration of flight will be 10 degree 4 minutes, 10 hour 4 minutes minus 9 hour 46. That is a duration of only 18 minutes. So that means you have flown that flight for a total of 18 minutes. Okay. Now you are flying a rumline track of 270 degree westerly. So that means let's draw this earth on the next page. So always when we are talking about longitudes, we have the same diagram: North Pole 0 degree, 90 east, 90 west, 180 east and west. So currently we are at longitude 130 degree 14 minutes east. 130 degree east. So correction. So it will be here 130 degree 14 minutes east. Okay. So that is your longitude. Next question. Next part of the question. You are at flight level 100 and the other conditions of your flight is given: flight level, temperature, Mach, wind. So what is your aircraft position at 10:04 UTC? Now with this 2 airspeed which is given to us, where is it? Correction, we have been given speed of Mach 0.8. Now putting this value in the CX3, you will get TAS, true airspeed. So let's find that out. So I will exit from here. I will show you how to put that. So open your CX3. For those who don't have CX3, you can open that in your Google. So over here. So go to airspeed option. Now they have asked, we don't have TAS, but we have outside air temperature given to us. Now which is in Fahrenheit currently. Convert that unit by pressing convert unit button here. So you can convert Fahrenheit into Celsius by pressing convert unit button. So now you have the option Celsius. Now what is the Celsius given to us? We have a temperature of 0 degree Celsius. So put 0 degree in that place. So outside air temperature is 0. Next. So press the orange button after putting 0 and come down to Mach. So Mach is 0.81. Next. So next point we have wind component, temperature 0, Mach 0.81, flight level 100, flight level 100. So pressure altitude here put 10,000. So now you have a true airspeed of 521.67, approximately 522 knots. Calibrated airspeed you have got 454 knots. So that we don't require. So true airspeed is 522 knots. 522 knots. So true airspeed equals to 522 knots. What is the wind component given to you? You have a wind component of tailwind of 35 knots. 35 knots tailwind. So whenever you have a tailwind, your ground speed will be more than true airspeed. So ground speed will be equal to true airspeed plus tailwind, which is equal to 522 plus 35, which is equals to 557 knots. So your ground speed is how much? 557 knots. Time of flight is how much? 18 minutes. So now when you have speed, you have time. Okay. What else can you calculate? You can easily calculate distance. So distance will be equal to speed into time. Speed is 557 knots. Time is 0 degree 18 minutes. So distance that you have covered during this 18 minutes of flight is a total of 167 knots. A total of 167 nautical mile. Correction. So the distance that you have traveled is 167 nautical mile. So first, let's start with the basics. We had two starting time and the ending time. So with that we found the total duration of flight. Then with the help of this data, we calculated ground speed. Okay, we calculated true airspeed, and then further applying tailwind to that, we calculated ground speed. Now when we have ground speed and time duration, we can calculate one more element, which is distance. So distance, speed into time is 167 nautical mile. Now what kind of distance are we talking about here? We are talking about rumline distance. Okay, this is a rumline track. So this distance is nothing but your d long in minutes into cos lat, which is equal to cos latitude is 36. Okay, so same latitude for both locations because aircraft is flying along the same latitude rumline track. Cross multiply d long in minutes is 167 divided by cos 36, which is equal to 206 minutes, or divided by 60, 3 degree 26 minutes. 3 degree 26 minutes. So that is d long. Now you know you are flying westerly direction or clockwise direction. So your final longitude will be to the clockwise direction of the initial longitude. When you go clockwise in the eastern hemisphere, your values decrease 130, 90, 0. Okay. So your new longitude will also be lesser in value compared to the initial longitude. So write down new longitude equals to initial longitude minus d long in minutes. So initial is 130 degree 14 minutes. D long is how much? 3 degree 26 minutes. So new longitude will be equal to 130 degree 14 minutes minus 3 degree 26 minutes. So that will be equal to 126 degree 48 minutes. Eastern longitude. So your new longitude is 126 degree 48 minutes east. And your latitude, what is the position they have asked? So position is made of two things, a latitude and longitude. So latitude will be the same, 36 degrees south. Longitude will be 126 degree 48 minutes east. Okay. So in exam, pay attention to the directions, south, north. They can give 38, 36 north, and you may select that option. So everything goes wrong. So that question you will get 0 marks. So even though the values, the options will have confusing values, 36 north, 36 south. So pay attention to the coordinates as well as the directions that you are putting in front of them. So it is 36 south. Read the question carefully. And 126 degree 48 minutes east. You are in the eastern hemisphere. Let's go to next question. At which latitude is the departure in nautical miles? So your departure is nothing but your line distance. So they are saying at which latitude is your departure equal to the difference in longitude. So at which particular latitude your line distance will be equal to d log in minutes. So let's use line formula. Line distance is d long in minutes into cos of latitude. So according to this identity, line distance to be equal to d long in minutes. So instead of line distance, I can put d long in minutes, rewrite this formula into cos of lat. We have to find out lat. Now when left side is equal to right side, d long will get cancelled. So we have currently 1 equals to cos of lat. So latitude will be equal to cos inverse 1. So your latitude will be equal to 0 degree. So the answer to question number 1 is 0 degree. So at 0 degree latitude, okay, at 0 degree latitude, your departure will be equal to difference between two longitudes. Okay, let's go to question number 7, part 2. At which latitude is the departure is nothing but your line distance equal to half the difference between two longitudes in minutes. So you have to find a latitude at which line distance will be equal to d long divided by 2. So the formula for that is line distance equals to d long in minutes into cos of lat. So line distance will be equal to d long divided by 2 equals to d long into cos lat. So d long gets cancelled. You have half equals to cos of lat. Therefore, latitude will be equal to cos inverse half. So therefore, latitude will be equal to 60 degree. Cos 60 is half. If you don't know that and you want to use scientific calculator, you can press the shift button on the top left corner and then press the cos button. So you will get cos inverse in the screen. And then you can write half. Shift cos inverse 0.5 is 60. 0.5. So this is how you do this sum. Now let's go to next part. At latitude 52 degree north, what is the departure between two meridians? So direct straightforward question. So let's write line distance is your departure. It is equal to d long in minutes into cos of latitude. So d long is how much? One is in the eastern hemisphere and another is in the western hemisphere. Okay. Now 136 degree. This is a very tricky sum and very good sum. 16 minutes. Now when coordinates are in different hemispheres, to find d long between them, you will have to add them. So plus 43 degree, 42 minutes, 44 minutes is 180 degree. Now when the sum of two longitudes is 180, that means they are on meridian and anti-meridian respectively. Okay, so let's put 180 degree here into 60 to convert it into minutes into cos of 52. So the answer will be 180 into 60 into cos 52, 6,649 nautical miles. 6,645 nautical miles. So your Ramline distance, okay, will be 6,649 nautical miles, meaning this is your Earth. Okay, let's draw our longitudes like we always do. North 0, 90 west, 90 east, 180 east and west. Now we have one longitude 136 degree, 16 minutes west, and another at 43 degree, 43 degree, 44 minutes east. Correct? So both are on meridian, anti-meridian, right in front of each other, which is 180 degree. So if you follow a Ramline track, if you go from westerly direction like this, will be equal to 180 clockwise, or if you choose to go anti-clockwise, same distance d long 180 degree. So go easterly direction or westerly, it is 180 degree Ramline d long, and either way the distance you will have to cover will be 6,649 nautical miles. The next part of the question tells you, at the same latitude, what is the shortest distance? So instead of going right around the earth for 180 degree, going full around the earth like this 180 or like this 180, choose another route or select some other flight route which will give you a shorter distance than the Ramline distance. So when two meridians are, when the locations, okay, if you have done the theory, so if you're not understood the theory well, or if you have some doubts, I suggest that you watch the video that I have made on this departure and convergency chapter and the shape of the earth chapter, that when meridians and anti-meridians, when these two meridian anti-meridian exist, they form a great circle. So a meridian and its anti-meridian together form a great circle. Okay, so if this is your earth, let's say this is the north pole here, there is a meridian on one side of the earth which is 0 degree. On the other side of the earth, that is western hemisphere, there will be its anti-meridian 180 degree. So when you travel along a meridian, pass through the pole, you will automatically transition to another meridian, to its opposite meridian, which will be its anti-meridian. Okay, and so on and so forth. If you continue this 360 degree circle, you will soon reach this point from where you started. It is, so both are meridian, anti-meridian. Okay, so what happens, both are located on 180 degree difference in longitude. So one meridian and its anti-meridian complete make one great circle. They make a great circle, and a great circle route will always give you the shortest distance compared to Ramline. So always when two longitudes are on meridian and anti-meridian, it is always good practice to fly a great circle route passing through the nearest pole, or it can pass at the pole or the nearest to it. So in this case, you will follow a great circle track from the initial longitude, fly northerly heading Okay, fly northerly heading first. Then at the North Pole, and after passing North Pole, you will fly a southerly heading and automatically transition the to its anti-meridian, which is this anti-meridian. Okay, so this red color track is nothing but your great circle track, and you can see it is a straight line. So straight line is always the shortest distance between any 2 points, correct? So this is what is the case. So now to find we have been told to find the shortest distance between these 2 points. In other words, we have to find the great circle distance. So what is the great circle formula? D lat into 60 degree. So when we are dealing with great circle, our figure will change and it will become something like this. So we have equator, we have north pole, we have south pole. Now we have one latitude at 52 degree north. Both positions are at the same latitude, 52, 52. So 52 degree north, one longitude is 136 degrees 16 minutes west. Let's say this is your western hemisphere, this is your eastern hemisphere. And another longitude is same, 52 degree north, 43 degree 44 minutes east. So now you are going from 136 degree west to east, like this. So what will be the total distance? D lat. So let's calculate the difference between the latitudes. The difference between North Pole and 52 will be how much? 90 minus 52, 38. North Pole is 90 degree latitude. Same when you enter this side of the hemisphere. अमलाने टाकलंय, मी टाकलंय सुद्धा. So the difference between 90 degree north and 52 degree north is 38 degree. Difference between 90 and this 52 degree north is another 38. So total D lat will be 38 plus 38, 76. When you put 76 and you multiply by 60, you get answer 4560 miles. So compared to Ramline distance, which was 6649 miles, Great Circle is definitely less than that, 4560 nautical miles. Let's go to next question. So the answer to this question is 4560 or 60 nautical mile. Now here again we have aircraft which is leaving position L at latitude 37 degrees south. So we have L at 37 degree south. 37 degrees south. It is going in westerly direction at a speed of 310 knot. The next piece of information says M is reached 80 minutes after leaving L. Okay, that means the time that we have in traveling from Lima to Mike is 80 minutes, 1 hour, 20 minutes or 80 minutes. Now when we have speed and when we have time, we will calculate distance. So distance is equal to speed into time, 310 into 1 hour 20 minutes. So that is equal to distance will be 413 nautical miles. Now this distance is nothing but your Umline distance. When you are going from L to M at a heading of 270 along a fixed latitude, so that is your Umline track. So this is nothing but your Umline distance, 413 nautical mile. Use your formula D long in minutes into cos lat. So 413 is equal to D long I do not know because I only know one longitude. I don't know either of longitude, either longitude in this case, into cos of 37. D long in minutes, 413 divided by cos 37. So that is 517 minutes, or 8 degree 37 minutes. 8 degree 37 minutes. So that is your D long. So from here, so over here, let's stop here because we won't be able to go any further or go ahead because we don't have any longitude. So there is no point. So we will have to stop at this point. Now let's go to next route of flight, which is M to N. Now when going from Mike to November, you fly a southerly heading. So M to N, you will fly a heading of 180 and the speed will be equal to 280 knots. Now what is the latitude of M? At the latitude of M is the same as latitude of L, which is 37 degree. Now when you fly a great circle track, okay, when you fly a great circle track, you will have a different latitude for November. So a latitude more than 37 degrees. Since you are in the southern hemisphere and you go in the southerly direction, your latitude value increases. So the value of November will be more than 37. Next point, from November to Papa, you fly a heading of 090. Okay, you fly a heading of 090 and Papa is directly south of Lima. Papa is directly south of Lima. So that means the longitude for L will be the same as longitude for P. Next they say P is reached 93.5 minutes after leaving N. 93.5 minutes after leaving November and the speed is 250 knots. So 250 knots is your speed and time is 93.5 minutes. 93.5 minutes. So when you have time and speed, you can calculate distance. Now this again will be your Rumline distance since you are flying 090. So Rumline distance equals to D long in minutes into cos lat. So distance here will be speed into time, which is 250 into 93.5 minutes divided by 60. Convert that minutes into corresponding hours. So 93.5 divided by 60 is 1 hour 33 minutes. So 1 hour 33 minutes into 250 will be equal to 389 nautical miles. So 389 equals to D long into cos of latitude. Okay. Now M and L has a D long value of how much? 517 minutes. Now the same D long value will be applicable to the longitudes between November and Papa. Why? Because it's given clearly in the question that Papa P, point P is, which is Papa, is due south of L. So that means directly to the south of L is P. So that means the longitude of L is the same longitude for P. Longitude of November is the same longitude for M. So that means both the d long between them will be equal to d long between these two values. Since both, all four have the same two longitudes, okay, uh, have the same two longitudes which are relevant to them. So both M and L are bound by two longitudes, and November and Papa, N and P, are also bound by the same two longitudes. So let's put this value of d long here. So cos of latitude is 0.75. So latitude will be equal to cos inverse 0.75. So that is equal to 41 degree 24 minutes south. We are in the south hemisphere. Okay, so first we draw L to M distance d long. Then M to N we didn't have any much information. Okay, we only knew that this is a great circle track and we stopped there. N to P, same. We had speed 250 knots, time 93.5 minutes. So from speed and time we calculated distance. That is your rumline distance. So we calculated rumline distance. From that we got latitude, which is 41 degree 24 minutes south. That means, so P is at 41 degree 24 minutes south. So N is also at 41 degree 24 minutes south. That's it. Okay, and M was at what latitude? The same latitude as L, 37 south. So this is 37 south. Now, let's come back to the question. What is the distance between M and N? Very simple. Now onwards it's very simple. Distance between M and N is nothing but your great circle distance. It's nothing but your great circle distance. So great circle distance, you change latitude. Right, 37 south has become 41 south because you are in the southern hemisphere. And when you are in the southern hemisphere, 0 degree equator, and you go southerly direction, your latitudes will increase. In the northern hemisphere, if you are in the northern hemisphere and you go southerly direction in the northern hemisphere, your latitude values will decrease from 90 to 0. In the southern hemisphere, they will increase from 0 to 90. So pay attention to that. So great circle distance formula is d lat into 60. So great circle distance d lat is 41 degree 24 minutes minus 37. 4 degree 24 minutes into 60. That is 264 nautical miles. So answer part 1 answer is 264. Now time. Time will be distance divided by speed. Distance is 264. Speed is how much? It's given. You're traveling from M to N at 280 knots. So put 280 there. So time will be equal to 264 divided by 280, which is 56 minutes. 56 minutes. Okay, so this is the end of our answer. So this is how you do the sum. Although it looks very big in question, but if you divide that into small and small segments like this, L to M, we first took the first root, then solved it, then M to N, then N to P was solved. Here we found latitude, and with that, once we get the latitude 41 degree 24 minutes south, we know that the same latitude applies to November. So we know this latitude and we know the top latitude 37 south. So now it becomes easy to find great circle distance and the great circle time to travel. With this we have come to the end of this lecture. I hope you have understood everything. and you have learned something new today. And do subscribe to this channel and share this video with everyone. We are going to continue with this lecture again in the next video where we will solve the next sums. So I request you all to be present in that video. Don't miss the lecture at any cost. Thank you.